Okay, this is the June 2022 P1 paper. It's question 8. It's a very unusual looking question here. It's going to be radians and arc lengths and areas of sectors, but I'll give you just a few seconds to have a look at the information on there. Won't worry too much about what we're going to be asked to do later on. We can go through that bit, but just actually working out what we've got in front of us for this diagram. So while you're reading that, you can pause the video if you want. I'm just going to get my lovely bit of artwork that I've done already in preparation. So for me to try and explain it to you, then I wouldn't do this in the exam obviously, but this is just an explanation to you. What they're saying in this question then is that you've got this fan, it's a ceiling fan, and it's made up of 3 shapes that are all the same. The pink one, the yellow one, and the blue one are basically the same shape, just repeated. And then they're going to ask me various different questions about it. So in order to do a little bit of work on this then, what I'm going to do first of all is I'm going to support myself by actually, right, let's draw out what we've actually got there. So we've got a sector that's OCD here apparently, and then another sector that's OAB. So let's put that all on. We've got O, D, C, B, and A here. So now I can clearly see that one of those fans there, this pink thing, is basically just 2 sectors stuck together like that. You can go back and read the information, but I've already taken the information off the diagram. They tell me that that length's 84. They tell me that that length there is 9. They tell me that the arc AB is equal to 15. And they tell me something that's not brilliantly helpful. They tell me that angle there, I'm just going to mark it as theta at the moment, but they tell me that theta is 2 pi over 3. And then the question for part A, what we're trying to do for part A, is we're trying to work out what CD is. And actually, I think they tell me what it is. Yeah, show that CD is equal to 35.9. So coming back to my diagram here, how am I going to do that then? Well, what I'm going to do is, if I want to work out CD, then really I need to work out that angle, because then I can use those 2 bits to work out the arc length. So how am I going to work out that angle? Is that really first I need to work out this smaller angle, AOB. I need to work out that one, and I can do that. If I've got 9 and 15, then I can work out this one, which means I can work out this one, which means I can work out that. All I now need to do is to show the examiner what I'm doing there. So in terms of whether I'd actually have this drawn in my answer to the examiner, or I might not, but what I certainly would do now is when I'm going through and doing my bits here, hopefully this will be clear to you and clear to the examiner what I'm doing. First of all, I'm just going to look at the sector OAB here. And for this sector, I'm going to try and work out what theta is if I've got 15 and 9 there. Perhaps using theta too often, but theta in this one, the only reason I'm using theta is because my formula for arc length is L equals R theta, and I've got 15 equals 9 theta there, so theta is 15 over 9. 15 over 9 is the same as 5 over 3. So if I now look at my next sector, and again I'm going to draw my next sector out, the CD sector this time. If I now look at that one, let's draw that, where this time I've got OCD. Let's just call this alpha for a second, just so that I can distinguish between them. 84 there. Hopefully that would be clear to anybody looking then that I'm doing that angle in there. So on this one now, I know what alpha is, because alpha will work out to be 2 pi over 3 minus 5 over 3. Does that make sense to you, that we now know that angle's 2 pi over 3, that bit there is 5 over 3, so that's just 1 subtract the other one. So if I do that, sorry, put that back in. I'm going to leave it like that. I'm not going to do anything with that at the moment, because now I can use L equals R theta again. So L equals R theta. L, which is my CD, that's going to be equal to 84. I'm not even going to tidy that up as a decimal. You could do, nothing to stop you writing down the decimal equivalent, but I generally tend to give the exact answer to the very end and then round it up. That gives me 35.929, which then rounds up to what they asked for, which was 35.9. Lovely. Okay, so I've done part A. What does part B say then? Part B says, can we find the perimeter of the face of the fan? So it really does rely on us actually understanding what this diagram is, otherwise we're completely stuck with this. But they do these sorts of questions in Radians quite often. So the perimeter of this shape. The perimeter of this shape then is 3 of those, because they're congruent shapes. So the pink one is the same as the blue one is the same as the yellow one. So I want 3 lots of CD, and I already know what CD is, it's 35.9. I want 3 lots of the smaller arc length there, and we know what that is, because in the question they told me that AB was 15. So 3 lots of 35.9, 3 lots of 15, and then I've got this straight line, and I've got the same straight line, 1, 2, 3, 4, 5, 6 of those. And actually that's not a difficult line to work out, because they told me the whole length was 84 and that bit there was 9, so it's just 84 take away 9. It's going to be 75. What I now need to do is to make that clear to the person who's marking my work. So part B, the perimeter. And just in terms of time here, it's how long you want to take to do this. I think if I've got these numbers written down like that, and certainly in terms of the length of this video, I'm going to do just that and write that down. What you could have done was to say, I don't know, arc length CD times 3, arc length AB times 3, and length CB times 6 if you wanted to. I'm not going to. I've already done it, as you can see from all my colourful diagrams. If you do all that and multiply it all out, or add it all together, that comes to 603 centimetres. And then part C. Part C says, can we find the surface area of the fan? Again, just keep going back and just checking these nearest centimetre. This next one's going to be 3 sig figs. That one was 1 decimal place when we're going through and doing them. Right, can I find the surface area of the fan and give my answer to 3 significant figures and make my units clear? Well, unit's going to be centimetres squared. Right, so if I want the area of this one then, actually, I'm going to go back and look at this. The area of this is simply going to be the area of one blade, which is one sector plus the other sector, and then you've got 3 blades, so just times that by 3 once we've got it. So, if I'm going to do that, let's just make it clear to the examiner what I'm doing. Area of one blade is going to be area of sector plus area of sector. Don't know whether I necessarily need to write those bits down. And it's going to be half r squared theta plus half r squared theta, but where obviously for one of them we've got a half 84 squared, and that angle was, I'm going to leave it again as it was, 2 pi over 3 minus 5 over 3 plus, and then the other one was half, and the radius of that one was 9, and the angle of that one was 5 over 3. Just make sure, you know, this is, if you've got this far with the question, you don't want to be making mistakes about picking up the right lengths and the right angles there. This video has been long enough, I'm just going to let you work that all out to yourself. It works out to be 4,730 if you do it, first of all, to 3 significant figures, which it did say in the question, and secondly, make sure you're putting your units on there. That's 5 marks for that bit there, so they'll be taking marks off for accuracy and they'll be taking marks off for not answering the question. Right, yeah, pretty beefy question that one, but hopefully that all makes sense.